Hey everyone, let's take a look at number 6 in section 7.3. We're going to evaluate this integral right here using trig substitution, trigonometric substitution. So first of all, you need to know which substitution we are going to do. Our independent variable here is z. Is this going to be z equal a sine theta, a secant theta, or a tangent theta? So you do need to know how to figure that out, and I'll show you basically where the problem will be if you choose incorrectly. The correct choice will be z equals a secant theta, and the way to find a, right, this will be a squared, and so a being a positive value is going to be equal to 8. So I'm going to choose z equals 8 secant theta. In that case, dz would be 8, the derivative secant is secant theta tangent theta. So this gives me that relationship. And then here's the reason. When we look at the square root of z squared minus 64, right? Well, z squared would be 64 secant squared theta. If I factor that 64 out of there, I'll be left with secant squared theta minus 1 under the radical. Well, that, by the Pythagorean identity, is tangent squared theta. And that's the only one that will work. If you had chosen 8 sine theta, you would have sine squared theta minus 1. Sine squared theta minus 1 is not cosine squared theta, right? It's 1 minus sine squared theta is cosine squared theta. So that won't work. Neither obviously will if you will work if you choose 8 tangent theta, since tangent theta minus 1 is not secant squared theta. In fact, tangent squared theta plus 1 is secant squared theta. And so this is the correct choice. And notice when I take the square root of 64 tangent squared theta, I just get 8 tangent theta. So that's why this works. Okay, I also want to take a look at the fact that if z is 8 times secant theta, then secant theta is z divided by 8, right? Divide both sides by 8. Or theta is the arc secant or secant inverse of z over 8. If I go to my triangle here, my right triangle, theta being the acute angle here in a right triangle, secant is the reciprocal of cosine. If you remember, cosine of theta is adjacent over hypotenuse, so this must be the hypotenuse over the adjacent. Sorry for the scribbles there. The hypotenuse is z, and the adjacent is 8. I messed up the first time. Um, and so when we try and find this side b, notice we know that b squared plus 8 squared would be equal to this hypotenuse squared. That's the Pythagorean theorem. And then, so if I subtract 8 squared or 64 from both sides, I get b squared is this. And so the square root of b is, or b is equal to the square root of this quantity. Okay, so we'll use this later when we convert back from theta back to x after we integrate. So let's do the substitution. Our dz here, right, is 8 secant theta tangent theta. Our z cubed would be what? If I cube, I get 8 cubed times secant cubed theta. And then the square root of z squared minus 64 is 8 tangent theta. We have some simplifying that we can divide both top and bottom by tangent theta. And I can divide top and bottom by 8. I've got 1 over 8 cubed, which is 512. So I've got 1 over 512. And then also I can cancel 1 secant with this, and I'll be left with secant squared down there. Okay, so what's the antiderivative of 1 over secant squared? Well, don't really go crazy on that. If you just think about it, we just talked about the fact that secant and cosine are reciprocals, so 1 over secant squared is just cosine squared. And you should know how to evaluate cosine squared by now. We use the power reducing formula for cosine. Cosine squared is 1 plus cosine of 2x divided by 2, or 1/2 the quantity 1 plus cosine of 2x. So I'm going to do that here. Of course, my independent variable is theta, so cosine squared is 1/2 the quantity 1 plus cosine of 2 theta. And now I can evaluate this and find the antiderivative with a simple substitution. 1/2 times 1 divided by 512 is this quantity. The antiderivative of 1 with respect to theta is just theta. And then the antiderivative of cosine of 2 theta, with a little substitution, we're going to get 1/2 sine of 2 theta, right? So one thing you want to make sure you do right away, since we're going to convert back to the variable x, we want to express sine of 2 theta using the double angle formula, right? For sine, sine of 2x is 2 sine x cosine of x. And so we can write sine of 2 theta is this. Of course, 1/2 times 2 is 1. And distributing this fraction here over, I get this expression here. So I want to go back to x. How do I do that? Well, you see I have expressions for sine and cosine theta here in terms, I'm sorry, in terms of z, not x. We got to go back to z. That's our independent variable, not x. So I'm going to go back to this right triangle that I drew. Remember, what is sine of theta? Sine is opposite over hypotenuse. So b is this quantity divided by z. Cosine is adjacent 8 divided by z, right? Of course, the reciprocal of secant. And so that's how I got these two expressions. So replacing sine of theta with this expression and cosine theta with that expression. And theta, now for theta, you can just simply use this expression here. Remember theta, since secant theta is z over 8, theta is the secant inverse of z over 8, or arc secant of z over 8. And just cleaning this fraction up here, 8 over 1024 is just 1 over 128. Z times z down here. And this is our antiderivative. What a lovely function it is. And I hope this helps.